Hello and welcome to the podcast According to Sci-Faith, where we discuss topics revolving around the compatibility of science and faith. I'm Joshua Göcking and you're listening to According to Sci-Faith. Alright, let's start. So if you're listening to this episode, you might have noticed that there must have been a change because this episode is pretty long. This is due to some changes in the production of this podcast, and I want to explain it to you such that you understand how this podcast is produced from now on, and then you can understand the changes and know how you can listen to this podcast because there are some redundancies. Because it is like that, what I will do from now on is every 4 weeks I will produce a large chunk of 4 episodes, and I will also release them in one thing, like this what you are listening to now. This will be 4 episodes in one. And I will call those preview episodes, where you can listen to all of the next 4 episodes at once. This is for listeners who like long format podcasts and who have no worries about listening to a podcast who is 1.5 hours long, like this episode might well be. And for those who prefer a shorter version of it, for you we have also something. In the next 4 weeks I will release those episodes in individual form. So you can decide for yourself which one you want to have. Do you want to have all the episodes all at once, or do you want to hear them weekly in small parts? So I think this way you can have the best of both worlds. If you like long format podcasts, listen to the long one. If you like it in shorter versions, bit by bit, then listen to those. And it's also better for me because it makes it easier for me to produce large amounts of content. Okay then, let's start. Episode 61. Multiverse, Hidden Variables, or Random Chance. This is an article I wrote for the Studium Integrale Journal from the Studiengemeinschaft Wort und Wissen, which is a society in Germany where we argue about science and faith and how a biblical worldview can still be in line with scientific findings, and also where scientific findings deviate from the faith. We discuss it. We discuss how we can interpret these results in such a way that science is still in agreement with the statements of the Bible. So it's pretty interesting discussions, pretty interesting things, mainly focused of course on evolution and creationistic theories, but there's also space for physics, and this is the part where I engage with them, and I was able to write an article about my findings, or about what I have become to know in physics, and also to what I talk about in my book Sci-Faith, the compatibility of science and faith, about theories and worldviews. And I was allowed to write an article there, and this was released last year in May. And by now I was also able to translate it into English, and it is now available on my blog. So yeah, there you can read the whole article in English. And today in this episode, I will not read through the whole article, but I will read through the abstract and will shortly discuss the ideas that are behind it, so that you get an idea of what the article is about. And I really encourage you afterwards to open it up after you listen to this episode, open it up, the article, and read it completely through, because then you really get to grasp the whole content, the whole ideas. And I think it's really encouraging, especially as a reader who tries to maneuver the topic of science and faith and how they can be compatible. And this is all, as you might have already, if you're familiar with some of my content, you notice that I always put this in relation to quantum mechanics, because there you really can see this play out. So let's go through this abstract, and I will every one or two sentences or every paragraph I will make a short stop and discuss what this is about, say more to it, and explain a little bit of what I mean by the sentences I made. So let's start. The double-slit experiment shows that quantum objects have both wave and particle properties, wave-particle duality. So this is the main thing of quantum mechanics, that it has this weird feature that particles or the quantum objects on a microscopic level seem to have both a wave nature and a particle nature. And this is really odd because wave and particles are really completely different concepts. In addition to the type of measurement, has an influence on the outcome of the experiment measurement problem. So the type of the measurement you do has an influence on how the outcome of the experiment will be, which is really odd because usually in science you say what I do, or I'm as the observer, I'm not related to the experiment. I'm not part of the experiment. I'm like an external observer, so it should not affect the experiment in an ideal way. And in quantum mechanics, this is not the case. You have this measurement problem, which basically states that if you observe a state, then this will influence or affect the outcome of the experiment. Mathematically, the observations can be described using various approaches. For example, the Schrödinger picture, the Heisenberg picture, and the Feynman's path integral formulation. So this is from mathematics. There are certain ways to describe this behavior. So if you have new phenomena in physics occurring, the first thing physicists do is to try to describe it, and to describe it they use math. So you can really, often it is said, math is the language of physics, and this is really true. We formulate or we express something about physics in mathematics, in mathematical language. Of course, if you hear a physicist talking, he does not only speak in equations, he also uses English or German or wherever you are. Language, if it's an international society, then they use English. So in their papers they also always write in English, but they also speak in equations, and the physics itself is mostly or completely formulated in equations, in mathematical equations. So it's really the language of science, which I think you need to understand especially if you are this is slightly distracting from the point, but I think it's important to understand it, that if you are dealing with scientific facts, especially with physics, and you don't look at any equations and only at the explanations, or for example in explanations in popular science books and so on, you always need to take this with a grain of salt, because the real language physics is formulated in is maths. And if you deviate from this by trying to explain the maths in English language or in another language, then there's also something you lose, some information that gets lost, and then it can happen that there is some knowledge lost and that you come to false conclusions if you only go from that. But okay, that's just a side note, just that you know that if you really want to grasp all of physics, unfortunately for some people, you really have to grasp the maths behind it. Okay, but let's continue. Or one more thing to this, because this sentence is actually saying that there are certain pictures or certain mathematical descriptions of quantum mechanics. So what they did, the first physicists who came who were introduced to quantum mechanics, they found a mathematical description of what actually goes on there. So by this you have not really understood yet what physically happens, but you have a description of it in physics. So you can say, okay, using this mathematical formulation, I can describe what's happening physically. And those were the pictures they used, the Schrödinger picture, the Heisenberg picture, and then there's also Feynman's path integral formulation. So the Schrödinger picture is described later, and let me just say the Feynman path integral formulation is also very interesting because it's also very Yeah, but I recommend you to read the article there. I shortly describe it, and then you can see what's the interesting part about it. I think I also did some podcast episodes or wrote some articles about it, but if you want to have more information for this, then just let me know, and then maybe I can produce a podcast episode specifically on that topic. Okay, let's continue. According to the Schrödinger picture, the quantum objects are in a superposition of several states and are only fixed to one state by the measurement. So this is what the Schrödinger picture tells you. It says that there are every state that a particle or the quantum object can be in are with some probability they are taken, and they are only fixed once you make a measurement. So before you make a measurement, you cannot say in which state the particle is. The probability with which they are measured in a given state can be determined from Schrödinger's wave equation. So this is the equation that is given. I think many of you might have heard of it, Schrödinger's wave equation or the Schrödinger equation, which gives you this wave equation, which basically gives you the probability to find a particle in a specific state. For example, to find a particle at a specific place at a certain time. And continuing, the interpretation of this equation is the subject of controversial debate, and it has been shown that they can be interpreted in different ways. So as we said before, there we have the mathematical description. There we also already have three descriptions. Maybe there are more, but we know specifically of these three that can describe all of quantum mechanics mathematically, and there's no controversial debate about which is the proper one, because everyone knows, okay, you can use that one, you can use that one, and some fit better for this for one purpose, and some fit better for another purpose. For example, in pure quantum mechanics, you usually use the Schrödinger or the Heisenberg picture. So usually it's the Schrödinger picture. The Heisenberg picture, or a combination of Schrödinger and Heisenberg picture, is used usually if you have interactions in place. And once you go deeper down the rabbit hole, so to speak, once you go down to quantum field theory, where you also put in relativistic effects, there at some place the Feynman path integral is pretty useful, and there you use also this approach. So it's just a matter of which is more convenient for solving the equations you want to solve. So there's no controversial debate about now this is the right or this is the wrong. It's just different tools that can be used for and that are more convenient in one way or less convenient in another. But then there's a different point of interpreting these results. So really saying what does happen on a physical level. So you move yourself away to some degree from the mathematical description and really try to understand on a philosophical level what happens on a subatomic level. What does it mean that I cannot say in which state a particle is unless I measure it? And before there is no way of telling. Not only no way of measuring, but no way of telling. There's no consistent way of speaking of a particle in a certain state if it is not measured in that state. So this is there really is controversial debate about what this means, and also what it means that I can only give a probability of finding a particle in a certain state. What does it mean that it is not determined, that it is not determined from its initial conditions in which state it will be? And there are certain interpretations, and in the continuation of the article I talk about this. So let's continue with the abstract. The most common is the Copenhagen interpretation, which state that nature actually behaves in this way. The measurement problem therefore shows the limit of what science can describe. So this was the first interpretation people came up with, for example, Heisenberg and Niels Bohr, and they initially formulated it, and what it basically really says is, okay, this randomness, this random part of is a part of physics, is just the way the world works. It's just this way, and nature behaves this way, and it shows us that there is a limit in science. It's we cannot go beyond the limit of these randomness of nature, so to speak. And this is very popular, mostly due to the reason that you, not due to philosophical reasons, many or most physicists I have met would disagree on a philosophical level and would say, no, that's not how I really deep down in myself think that nature works. But it is popular because it allows you to say, okay, let's close the topic. Nature behaves that way. It doesn't make any good to speculate around and around instead of solving the equations we have at hand. So it's a pragmatic approach. It's pragmatically saying, okay, we just say it is like that. We cannot prefer one interpretation over another because there's no way to scientifically prove them, at least now. And so we just say, we just use this Copenhagen interpretation and we continue calculating. So as one physicist once said it, shut up and calculate. So this is the idea behind it. So stop thinking about all the philosophy behind it, just calculate. But then there are many other interpretations which, if you talk to people what they think philosophical about this topic, where they say, no, the Copenhagen interpretation, I don't believe that, where they go more in these directions. And there's, for example, or let's continue in the abstract there, I name one of them. The de Broglie-Bohm theory assumes that there are additional hidden variables that determine the state of the particles. These move on a pilot wave given by the Schrödinger equation. So this is a pretty popular one. In general, there's a whole class of hidden variable theories. Albert Einstein was also one of those who was really thinking about these theories, or who preferred those to classical quantum mechanics. And there are many people who are inclined to believe these theories. There's a problem with hidden variables theories because there are inequalities that have to be met if there are local hidden variables. And Bell, a mathematician in the 60s, could show that these inequalities need to be fulfilled. And then it could be experimentally shown that these inequalities are not fulfilled in quantum mechanics. So the hidden variables theories, they are very restricted in what how they can be applied. But the de Broglie-Bohm theory is one that is formulated such that it does not run into these issues, and therefore it is valid in that sense. But still, it is you need to assume that there are no local hidden variables, which makes it a little bit harder to believe for some, I guess. And then there's also another very popular one. So let's continue in the abstract. In the many worlds theory, every state is assumed after a measurement, only not in the same universe. Each measurement here requires the creation of many new worlds in which one of the possible states is assumed. So each of the possible states a particle or a quantum object can be in is obtained in this interpretation, which would be ridiculous if you only had one world, because then every time you say I measure something, you would measure everything. That doesn't make sense, and that is not what we experience. So for this to make sense, it needs to be that we measure one thing in this world, but all the other states are measured in different worlds. And there we have many worlds, hence the name many worlds theory. So this leads us to ideas of a multiverse and all this stuff where we say, okay, there are many worlds out there, worlds where I am a rich, famous guy and so on. So all this kind of stuff. And I think this is also one reason why it is really popular, that oneself is or that there are many copies of our world where we have made completely different decisions and completely different outcomes and so on and so on. And I really discuss also the problems on my side, the problems, especially philosophically, with this worldview and also what's behind it. Because as you might have noticed, the de Broglie-Bohm theory and also the many worlds theory, what they do is basically they use quantum mechanics to come back to a deterministic worldview where you don't have this indeterminism of quantum mechanics, meaning the fact that everything depends on probabilities, that you can only give probabilities for a certain outcome, and that nothing is determined by their initial conditions. And with these alternative interpretations, you get this back. You get determinism back, not in such a way that we can say foretell the future, since we know the outcome of every measurement. Not in this way, but in a general philosophical way, that we know everything is determined, although we cannot determine it ourselves. But still, the philosophical component of everything being determined is preserved by this. And you can also see, if you look into the worldview of many who propose these theories, you can see that this is a worldview they hold on to, that they, many of them also believe, for example, do not believe in free will, since they believe that we are just material beings, and that everything that happens is just electrons and neurons firing in our heads, and so on. And so everything that happens is completely determined. So if you make a decision for one thing or another thing, that's not your free will making this decision. It just appears to you this way, and actually it's just the way the world works, and you are just part of a huge machine. And people who hold this worldview usually also prefer deterministic theories or interpretations of quantum mechanics. Okay, with that, let's continue. Despite their differences, all these interpretations can conclusively explain the double-slit experiment. So this is what all these interpretations have in common. They can all describe the data of quantum mechanics. They can all make the same statements, the same conclusions, and so on. And this is this is the good thing and also the bad thing, because it means they can all be true, but it also means they cannot be false. There is no way of verifying or falsifying which of them is true and which of them is don't true. So we have to allow all of them. And there's therefore a plentitude of interpretations of quantum mechanics that you can have. So if you want to do this exercise, you can just go to, for example, Wikipedia and type in interpretations of quantum mechanics. And there's a huge article with different kinds of interpretations, and the list Wikipedia offers is not even complete, I think. So everyone can have their own interpretation of quantum mechanics, and if you look among scientists, many of them have. So there are multiple different interpretations, and you cannot tell which one is right, which one is wrong, unless you really find a mistake in one of those interpretations where it really contradicts the scientific data. But there are a plentitude of different interpretations for this that you can have and that you cannot rule out by scientific means. And this is also something in this article. So in this article, it's not so much about interpretations of quantum mechanics itself, but I use this as an analogy for something greater, or for something regarding theories in general. And this is in the last sentence of the abstract. I lead to that. And there I say, similarly, many natural phenomena can also be explained by both naturalistic evolution as well as supernatural creation. So this is the statement that I make, that I say, as you have these many different interpretations of quantum mechanics, who are all different, who make all different statements, who even in their basic concept, in their basic philosophy, can be completely different, from deterministic to completely indeterministic. So in the same way that you have that, you can have for a general theory, like the theory of quantum mechanics, the theory of gravitation, the theory of also not physical or not physics theories, but maybe biological theories, like the theory of evolution. But if you want to go back to physics, like the theory of the Big Bang, and so on, you can have also different kinds of interpretations. The data is firm. The data is fixed. as far as their errors go, the data is fixed. But the interpretation of this data, there are different or can be an alternative interpretation that describe the same data in the same way, but yield different interpretations, different philosophical contexts. And in this way, you can describe, for example, it should be in principle possible to describe the findings of biology, the findings of fossils, and the things it should be possible to describe them in terms of an evolutionary theory as science does today, or as is established in science. But it should also in the same way be possible to describe it through theories of supernatural creation. Or if we go back to the Big Bang, we can describe the Big Bang using the theories we have right now. We will go into some of it in a later episode, where we go about the Big Bang and the expansion of the universe, and then the inflationary period and so on. We can describe it in this way with its 13 billion years of expansion and so on. This can describe it in this way, but we can also find a description of it which is more in a supernatural creational way, which also describes exactly the same data. So this was the abstract to the article I wrote. So if it catched your interest, I really recommend it to you. So go to scifaith.substack.com and there you can read the article in full. Episode 62, the Physics Nobel Prize 2023 and lasers. So 2023 was also a year in which, of course, the Physics Nobel Prize was awarded. And in this year, it was awarded to 3 physicists. And they were Anne L'Huillier, I guess it is pronounced, I don't know, of the University of Lund, Pierre Agostini of the University of Ohio State University in Columbus, and Ferenc Krauss of the Ludwig Maximilians University in Munich. So they were awarded the Nobel Prize for their research on attosecond light pulses, which is a pretty interesting topic, pretty groundbreaking research. So attoseconds, it's a really, really small number. So just to illustrate this, you might know milli, you might even know micro and nano. So those are steps you can go to show how small a thing is. So milli is, for example, a thousandth, and then it goes in 1,000 steps. So micro would be a millionth, and then nano is a billionth. And this way it continues. Afterwards there's pico, and then there's femto, and then there's atto. So atto is a really small amount, and it is really difficult to get to such a small layer for once, because this is the level at which atoms move in electrons move in atoms. So it's a really, really short period, and it used to be not accessible by light or by lasers. But before we describe how they did it, how they made this possible, I think it's best to first explain how a laser works and what a laser actually is. So let us talk a little bit about lasers. So first, what does lasers stand for? Laser sounds cool, the word, but where does this word come from? And actually, laser is an abbreviation. So if you write it out, it stands for light amplification by stimulated emission of radiation. So this is what laser stands for. But what does this mean? So now we know what the abbreviation means, but maybe we are not the smarter unless you really know about the physical concepts behind it. So first, we start by explaining first the latter part, the part of stimulated emission of radiation. So for this, we need to go back to physics class and remember, or even chemistry class, remember what we learned there. So we learned that matter is basically made up of atoms, and atoms itself are not the smallest part yet. They are themselves made up of protons, neutrons in their nucleus, and electrons in levels around those. And they can have certain states. They can be in a ground state, or they can be in upper states, depending on how much energy they have. So I think most of you should know this back from school, that there are those different layers in which the or orbitals in which the electrons can be. And what then happens is that they can jump from one layer to another. If they absorb energy, they can go to a higher level, and if they give this energy back, they can jump to a lower level. And of course, electrons, or everything in nature, is always trying to reduce the amount of energy or it needs for something. So it generally tends to go to the ground state, to the lowest state of energy. But there are simple rules that, so for example, if you have an atom with more than just one or two electrons, like hydrogen, which only has one electron, but if you have like carbon, it has more than that. So if you have those, then there are physics rules about what is allowed. For example, you cannot have two particles in the same energetic level. So this is just forbidden by the reason for this is that matter particles are fermions, and fermions have this, for fermions, the Pauli exclusion principle holds, which basically states that two particles cannot be in the same energetic state. They have to be different in so-called quantum numbers, and they can be, so actually two can be in kind of the same energetic states because they have their own property called spin, and if they are different in this property, they can be in the same energetic state but with reversed spins. So therefore, for example, if you know from your chemistry or physics class, in the lowest energy level of those atoms, there were always two electrons that could fit in there, and this is exactly the reason for it. They differ in their spins, and therefore they can be there. As you might know, in the upper layers, usually there were 8 who could fit in there, and this is for different reasons, because there are different particle numbers that they can obtain. They can have their own angular momentum, and they can have different levels there. So there is more possibilities of different energy levels in those areas. So I hope this was not too complex, but this is basically the atomic model you learned in school, I guess. And now we want to describe this further, because now the question is, what can always happen, for example, is that one electron, by some energy that it absorbs, can get to an excited state, which we call it. So it can go from a lower level to a higher level by some excitation, usually using photons or light particles. And now let's assume we have such an atom where the electron is in an excited state. And now the electron decides, let's say, to go back to the ground state. So what it does is it goes back to the ground state, but now we know energy is conserved in physics always. Energy has to be conserved. So how can this be that it goes to this ground state? Because the ground state is less energetic than the excited state. So where does this energy go? It has to be released in some way, right? And the way in which this is released is by giving off light, giving off a photon, a light particle. And this can happen spontaneously, as we just described, but it can also happen stimulatedly. But this we will describe in a bit. So it will give off this light. And now you know that from quantum mechanics, we know that these atomic levels we have there, they are quantized. So there are they are at a specific energy level. This is not a spectrum where there's a continuous amount of levels. They are at specific energy levels. So it is a specific amount of energy that it takes from one atomic level to the lower atomic level. So there's a specific amount of energy. And now, if you know of the photoelectric effect, you know that energy for light, because light is emitted when an electron jumps from one level to another, to a lower level. So light, the energy of light is proportional to its frequency. So if you have high energetic light, then it will have a high frequency. If you have low energetic light, it will have a low frequency. So and the different frequencies of light you can see as different colors. So if it's in the visible spectrum, so the colors of light have different frequencies. So red light has a lower frequency, and blue and violet light has a higher frequency, and therefore you know also infrared is in the area of frequencies lower than what we can see, of light of frequencies lower that we can see, and ultraviolet light is in the frequency spectrum of frequencies higher than is visible to our eyes. So this is the way it works, and therefore each atom has, with its individual levels of energy differences between its atomic layers, has also individual photons of light that it emits when it jumps from one level to another. So there is a spectrum for each atom of these differences in light. So where these difference in energy corresponds to a certain photon that is emitted, and this has a certain frequency. And so you have in this way you have a light spectrum for every atom, and this is really important. For example, also in astronomic observations, when we see the light that we observe from other stars or from other objects, then we can know which elements they are made of, because we know this is the light of this and that part. For example, we know this light comes from is from the energy level of hydrogen, and so we know that it was originally emitted from an hydrogen atom. But this was a big little bit lost track, but I think it was really good to understand this, because now we know how light is emitted from an atom. The problem with spontaneous, what we now described spontaneous emission, is if an electron spontaneously decides to emit radiation, then the direction in which it is emitted is completely random. So there is no way of foretelling in which direction the light will be emitted. It will just be any direction. So this is, in a laser, this is really not what we want. We want it to have a certain direction such that we can use this light to point it somewhere. Therefore, we need to find another way of getting this light to be emitted. And there, luckily, is the effect of stimulated emission. And this is also happens with atoms. And this is happening, let's say we have an atom in an excited state, and there is a photon coming towards it. And instead of the electron absorbing it and jumping to an even higher energetic level, it is triggered by this photon to jump to a lower level and emit radiation. Like if it would spontaneously emit radiation, but this way it is induced by this other photon. And in this case, we get this effect that the photon that the electron will then emit will point in the same direction as the photon that induced this emission. And this is what we mean in what the SIR part of the laser is, the stimulated emission of radiation. So what happens in a laser is that what specifically happens, we will see in a bit, but there are these emissions stimulated by photons, and then they move in the same direction. So what is now missing is the light amplification. So we not only want to stimulate emissions of individual photons, we want to have a lot of light. We want to have, lasers usually have a lot of light that they emit, not only individual photons, which would be nothing because it would just be too few photons to use for us. Especially if you have those high-powered lasers who can even cut through materials and so on. So we need an amplification of this light. You want to have a lot of this light. And how do we achieve this? This is achieved by a so-called process called population inversion. So basically, as we have said, atoms or electrons always want to be in the lowest state. So they always jump from the highest to the lowest states in order to reduce the energy they need. So this we want to turn around. We want to invert this population, basically, the population of the electrons in the atom. And this is done through a pump mechanism which enforces this population inversion. And this works, for example, that there's by absorption of photons, which always pulls the electrons in higher levels, higher energy levels, and then they jump back to a lower state, and there you get always this stimulated emission of radiation. But there is not, what is not usually used is a two-level system where you have the ground state and an excited state, because it can be shown that in this way population inversion cannot be upheld, and therefore usually a 3 or 4 level scheme is used where you excite the in a 3 level state scheme, you excite the particle from the ground state to a higher excited state, from which it then decays into a lower state, which is not the ground state. So there you have these 3 levels, and this way you can hold up such a population inversion. And this is usually how you get this laser to work, that you have it overly populate an excited atomic energy state, and from this you stimulate the emission to this or photons to this lower state, which is not a ground state in this 3 level scheme, and this light is then emitted, and what happens to the light we come to later. But now I want to shortly interpret this in a spiritual way, because I think this shows us also something for the spiritual way life, or for our life in the spirit, for our life with Christ, because it shows that if you think about it, everything going to the lowest energy, everything always trying to reduce its energy, to reduce its amount, it's kind of the way the world works. It's kind of how we see everything, kind of also if you look into the law of inertia, everything seems to be inert, seems to be trying to move as little as possible. It's physically not completely right. I get it. It's, if something is pretty fast, it tries to stay that fast, of course. But you have in it this, if you also know it from what you would talk to people around, if you talk of somebody who is inert, then it's somebody who's really not getting to move and really not getting things going, and which is considered to be a negative thing. Of course, you can interpret physics always in 2 directions, but if you would interpret it in this way, then you can also see that this population inversion is something which tries to turn this around, tries to turn us against this this way of the world, the way the world works, to always be inert, to just go along, to just go the easiest way, go the way with the least resistance, and so on. So I think what the Spirit wants us and what God wants us to be with being part of this new creation, He wants to invert this population. He wants to invert us in such a way that we don't go with the way of the least resistance, the way of least effort, the easiest way, in a negative way. Of course, He does not want us to work harder than we have to do stupid efforts which could be achieved in an easier way. He wants us to work smart and to act smartly, but He does not want us to go this way where we abstain from effort, where we try to go the easiest way, and in which as you have some experience to later realize, which is actually the way of most effort, of most fighting and so on, because in the long run it will get you more effort because you have been lazy before. So this is and this is I think what he wants to tell us, and there you see it also with the laser. There is a pump mechanism, and this pump mechanism, this delivers the energy. It excites these particles to this higher state. It delivers the energy for these particles to go to this higher state and to populate this higher state and stay in this higher state. So there it is, of course, also so that you don't need to make this effort yourself. You as the electron in this picture do not need to pull your self up from your bootstrap, but you are pulled there by the power of God, by the power of this pump mechanism, which in this image would be the power of God. So this is what you can see there. And also, if you look at it big biblical, you always see that God wants us to be in the high places, above everything. In Ephesians it says that we are placed in heavenly places, so where we are above all these worldly things. And I think this is also what this shows us, is that he wants us to be in the high energetic ways, where we are highly energetic, where we are not in the ground state and moved around by the ways of this world, but where we are above those things, where we are not in the sense that we are something better, but in a sense that we are transferred into his kingdom, and where we are concerned with his kingdom and not the ways of this natural world. So I think this is a pretty powerful picture in the spirit way, where it shows that what he wants to do be us. And if you think this image further, you also see what happens if this occurs. What happens? Light is emitted. So, light is emitted. Okay, the electrons then go to a lower state. This is maybe not part of the picture, but light is emitted. So we become the light of the world by being in this excited state, by being in this high state, by letting our population be inverted. We become the light. We become the light of the world, as Jesus says it, and we become alive to those who are not yet in this position, who are not yet aware of this possibility, who are not yet living in the power of God, and therefore are in this excited state. So I think this is a pretty powerful picture for what God wants to do with us and where he wants us to live. So to continue with the laser, what happens afterwards when all this light is emitted? Then they come into resonators to get them to a unified frequency. As I said, they have one frequency, but they still can by different radiations. So if some electrons do not use the 3-level scheme, but still jump to another energy level and so on, which can all happen, then you have a lot of noise in there, and you want to get rid of that. And this you do by resonators. This is basically two mirrors who are opposite to each other, and they are positioned in such a distance that when they are reflected, that everything but the frequency that you want to have obtained will be cancelled out by interference effects. And this way you have two mirrors, but you of course, you don't want the light to just bang around between those mirrors until the frequency is clean, but they just jumping around between the mirrors and nothing else happens. No, of course, the light has to come out at some place. So therefore, one of those mirrors is not completely reflecting, but to something like 99%. And so 1% of the light that is in this way put into a unified frequency will get out and come out of the laser. So this is the basic working of the laser. So I hope you could understand it in some aspect. So if not, then feel free to ask a question after this podcast episode. And what the problem with this is that this is on the area of femtoseconds. So one swing of one period of light is already on the area of femtoseconds. So it's too long to achieve attoseconds, which they achieved in their Nobel Prize winning research. So what did they do? So what they did is they radiated laser on matter, And as with the guitar, where you have, if you let something resonate, you have these harmonics that occur, or if you have they are in their frequency a lot of shorter than the original tone that you got. And in the same way, this happens if you put these laser pulses on matter, and there are shorter frequencies reflected or coming out of this matter, and this allowed to achieve attosecond pulses. So this is really pretty simplified, but I think that was the concept behind it. And today they even managed to get laser pulses as short as 50 attoseconds, which is really, really short. Just to illustrate this, in this time, light, which has, as we know, the highest speed, the light speed is the speed limit basically of the universe, and in this time, in 50 attoseconds, the light with the highest speed walks or travels a little bit more than the diameter of our DNA, and our DNA is 15 nanometers is the diameter of our DNA. So it's really, really small, and so this 50 attoseconds is really, really short, and this shows how much of an achievement this is, and this is really groundbreaking research. It has is assumed to have a lot of technical applications, but it's also for research really a breakthrough, because it allows a lot of things to be researched, and therefore, especially in regarding reactions, chemical reactions, and so forth, because everything that happens there happens on these time scales. So this was a really groundbreaking research, and therefore the Nobel Prize was well deserved. And I hope you could understand to some degree what this was about and what really was achieved there. All right, I think it's time for a short break. So before we continue, just make me some short announcements. If you want to know more about Sci-Faith, I really encourage you to go to my website, sci-faith.de/en. There you can find out more about this podcast, about my book, and about my blog. So you can read my blog. All the articles are also now in English, so you can read all of them. Also the article which I described in the first episode. And you can also learn more about my book, which is now available in English. So I really encourage you to get it as an ebook and read it, because there really much about what we are talking about is really discussed in a deeper way, and you will understand, I think, a lot more of what I'm talking about if you really have grasped those concepts. Also, there is a new book out, my latest novel, or my first novel also, Alien Thoughts. You can get it on Amazon as an ebook, and I really encourage you to read it. It's really exciting. I have gotten a lot of feedbacks. People really like it, and so I really hope you read it and also give it a 5-star rating, because this always helps people to know what a book is, to understand if it is something for them. And really, if you have the time, I really ask you to write a review of it, such that people really can know what a book is about, know if it's something for them, and so more readers can get aware of this book and can get to enjoy it. It also, of course, all this also supports me in my work, also on this podcast. It gives me more flexibility to produce new episodes. So I really am hoping for your support. Also, if you have ideas or requests or something that you want to have covered in this podcast, feel free to contact me at sci-faith.de/en and then use the contact form. There you can also subscribe to the newsletter, where you will get some special materials. So in the newsletter I write some of the thoughts that are usually not fit for blog posts, but still very interesting topics. So if you want to get this or get news, what happens at Sci-Faith, what's new, what's up, then you will get the latest news. You will really get there. And then I really encourage you to subscribe to my Substack. With that being said, let's continue to the episode. Episode 15, Darwin's Mistake and the Theocidy Question. Recently, I read a book. Last year it was that I read a book. It was actually in the beginning of the last year, so it's been a while. But I read this book by a historian, Tom Holland, so not the actor. There's a historian who is named the same. And he wrote about basically about Christian history. The book is called Dominion, and it is really about Christianity from its emergence to now how it has shaped culture, how it has participated in creating especially what is now called Western culture, and the effects it had and how profound those were. And this is really an interesting book. If you're a believer or an unbeliever, it is really an interesting book. Tom Holland himself, I believe, is not a believer in the sense that he really has a relationship to Jesus. I don't know myself. He only knows that, but that's the idea you're getting from the book. But he has an appreciation of the effect Christianity has on culture and on world history. So if you're really interested in this, he has also a podcast, The Rest is History, where he with another historian, Dominic Sandbrook, talks about these topics, not only about these topics, they talk about history in general, but he oftentimes brings in the effect Christianity has had on on world history. And it's really interesting, but it's also interesting to read a book because there he really dives in deep into it, and where you see how many things were really affected by Christianity. And he covers the certain areas also. He covers all of the Middle Ages, all of the time afterwards, the Renaissance, the Reformation, and also the modernity. And he comes also to the time where science came up, where the scientific revolution came up, and there he also covers, of course, Darwin and his theory of evolution, and how Darwin, as somebody who was believing in the beginning, more and more lost his faith, and how he argued about losing his faith. And if you read it in this context of this book, in the context of the history he describes before, I think you realize some mistake, in my opinion, Darwin made in his conclusions, because Tom Holland starts this by really describing almost at the same time or sometime before what happened. What he also credits Christianity to is the abolition of slavery. So what he writes there is when the colonization took place and the New World was discovered and colonized, of course, there was this one clergyman, or I think actually he was a Quaker. He was Benjamin de la Casas, Bartholomew de la Casas was his name, and he was the first one who was really critical about slavery and about the conditions in which the slaves were held in these colonies, and who really was the first who came up with this idea of being created equal before God, and that this also holds, of course, to the slaves that they were holding. And over the time, it led to slavery or the slave trade being abolished, and this was done by the British Empire, which at this time was really the world dominating force. It had the greatest navy, so it was ruling the seas, and therefore it was not only saying, okay, we won't trade slaves anymore, which was accomplished by William Wilberforce, also a Christian, who managed to get this through the British Congress at this time. And but this was achieved by the British, but they of course said, okay, if we are not trading slaves, we won't allow the others to have the same benefit, because that's bad for business, of course. But also they did not say it like that, but they also had spiritual reasoning behind it. Whether this was honest or not, you can argue yourself, but still they forced other nations and other cultures to abolish the slave trade also. And one of these cultures, which also was trading slave and never in their own religion had seemingly saw any contradictions to it up to that point, was the Muslim culture. And the British basically enforced upon the Muslims to abolish the slave trade in their nations. This is how Tom Holland writes it, at least, or that's the impression you get. And he also writes that they themselves then argued using this when they were forced to do it like that. They argued that they did it also because their laws basically implied that their laws also implied that slavery is wrong, and so on and so on. So whatever you believe, you can argue about whether this is true or not, but from the historic evidence this historian presents, it seems pretty believable to me. But what it really shows, and I think what really was the case, is that through this statements and through the world powers, the Christianly dominated world powers, arguing in such a way that is basically natural law, that every man is created equal and so on, that they were arguing from those are laws of nature and not laws of our religion, but they were arguing those are laws of nature and you need to oblige to. They did not come to these countries that were not Christian and say you have to do it because our God says so, but they came to them saying you have to do it because the laws of nature are saying so, because otherwise they could not argue this way, because what do other religions care about what your God is saying, basically? That's so they needed to have a different argument, and the argument was the laws of nature say so. And whether this is right or wrong, I mean, there were different, I mean, he goes also in, it would lead too much, but he goes also in on the Marquis de Sade, who had a really different idea what the laws of nature are saying. And if you look at it from a Christian perspective, you might also come to a different conclusion, as we see later. But this was the mindset that was created in this time, that the laws of nature are basically saying slavery is wrong and so on. All these, everyone is created equal and so on and so on. And this was the mindset with which I assume Darwin looked at the world, because this was the time, this was the society, this was the culture that he lived in. And when he then came to his theory of evolution and lost his faith with time, there was one thing he said what led to him to reject God. And there he said, I cannot persuade myself that a beneficent and omnipotent God would have designedly created the ichneumonidae with the express intention of their feeding within the living bodies of caterpillars. So this animal, which I had trouble to pronounce, is apparently is living inside the bodies of caterpillars, kind of like a parasite. And I'm not sure if it's eating him from the inside out or something else, but it's apparently something really bad for this animal. It's like parasites. Basically, he says, to generalize it, he cannot believe in a beneficent and omnipotent God if that he would designedly create a world in which there are some things like parasites. And this, I think, comes from his conviction, which he grew up with, that the natural law basically states, yeah, everyone is created equal, and we are all, and so on, we are all have all worth, and so on, which, as a Christian would say, is true, but a Christian would also acknowledge that we are living in a fallen creation. So the Christians always distinguish between the nature before the fall and afterwards. And after the fall, something in creation itself was falling. Animals are eating each other, humans fighting each other. A lot of horrible things are happening in this world. And this is not attributed to a God who wanted it to be like this, but it is attributed to the fall into sin, which came according to the biblical story by Adam, and which has since then been in this world and perverted this wonderful creation by God. So, and I think there's this mistake Darwin did. This is, you can see it clearly, I think, if you read the book, that he assumed something to be true, which was not true without God himself. So what basically the British people, when they enforced the abolition of the slave trade on the other nations did, they argued with divine revelations, but without God himself, but without a God behind it. They said it has to be like this by nature and not because this is how God wanted the creation to be, or the destined creation to be. And so they in essence they took out the fall of it. And then when Darwin looked at nature as it is in biology, in the animal kingdom and so on, when he looked at this as it really is, he said, yeah, but this is in stark contrast to what I have learned it is supposed to be. And since when it was pushed on others to treat everyone equally, it was basically God was basically kind of taken out of the equation in order to make the argument for those who did not believe in this God. Since this was happening, he could not really see that there is a difference, that there has been a fall which led to this nature as it is to not be as it is supposed to be. And I think this was the mistake that he made, and what basically led to him losing his faith and rejecting God. And I think this is clearly seen if one looks at it in this historical context. What Darwin is saying in the statement is basically the Theocidy question. This is very much discussed. If you argue with an atheist, at some point it won't be about, science says this and that, and therefore I cannot believe in a God. It's rather something, how could an beneficent and omnipotent God allow such and such? And then they refer to something like suffering and so on, that unfortunately is existing in this world. And as we already mentioned, the answer to this and the answer to the Theocidy question almost always is the case that there is a fallen nature, a fallen creation, and which explains why suffering is in this world. Because, of course, there are cases in which this correlation or this causation is not that clear or seems to be not there, but still one can usually explain it in these terms. But the problem oftentimes is that you cannot explain it directly from one point to the other. For example, there is this story in the Gospels where the disciples of Jesus ask Jesus about a blind man, and they ask who in their family or he was born blind, and they ask who has sinned that he has gotten this blindness. So was it his parents, and why did he then obtain it? Or because he was born blind, he could not have been it. And so and Jesus rejects that idea, and he says, okay, this is not, more or less, he says that there's not this direct causation necessarily, but this is leads to something else. But I think oftentimes, and that's my perception of it, asking this Theocidy question also is kind of neglecting responsibility for own actions, because if this, what we are talking about, the fallen nature, is that we are basically saying, hey, we brought this upon ourselves. By sinning, by not acting according to God's will, according to the purposes that God had for us, we brought all this pain and suffering on ourselves, and therefore this is not done by God. It's not that God creates the world in this way because he's some sadist or something. No, it's because we have deviated from what he had intended for us, and this way this pain and suffering came into this world, which is not from him but from the enemy, and the Bible is really clear on this. And therefore, I think it's oftentimes asking this question, to me, it's oftentimes neglecting responsibility. And there's a really good novel I recently read that makes this pretty clear. It's the from Dostoevsky. It's called The Brothers Karamazov. It's really a powerful novel. I really encourage you to read it. So it's a little bit long, about 1,000 pages, or a little bit more than that even. So, but it's really worth it because he covers a lot of topics in there. And among others, he covers this Theocidy question. And in this book, there are three brothers, and he describes the lives of them, the opinions of them. One of them is Alyosha Karamazov, and he is, in the beginning, he is a monk, and all through the book, he is a believer in Christ. And in contrast to him, there's a different brother, Ivan Karamazov, who believes in God, but who still rejects God because of these things, because he believes that a God who is a just God could not allow for such suffering to be in this world, or that he does not accept the justice of such a God. And there is a dialogue between Alyosha Karamazov and Ivan Karamazov in which they discuss these topics, and Ivan Karamazov brings a lot of examples and anecdotes towards this, and he tells of cruel histories that occurred then. So you have to remember this was at a time in Russia, in the Russian Empire, and this was a time where serfdom was still existent, and it was not still existent when the book is written. It was just recently abolished, but the remembrance of this time is still there, and the stories out of these times are still there. And Ivan Karamazov, for example, tells of one story where one landlord is really mean or really evil to the child of some of his servants, and he describes it then as how could a God allowed it. But what I think comes pretty clearly out of this story, at least to me, is where's the father in this? Where's the father of this child? Where's the mother of this child? I mean, they are mentioned there, but they are basically standing by and watching as it happens and allowing it to happen. And there you can already see the neglected responsibility, because even, I mean, it might be coming from a high horse for someone who never lived under the circumstances, but still, I mean, there would be, as a father or as a parent of a child, where no matter who attacks it, there should be this responsibility to say, no, you can't do that. No, that's my child. You have to pass me. That's at least what I think a parent is supposed to do in this situation. And there you already see, as cruel as the story is, as cruel as the behavior of this landlord must have been, there is still the neglected responsibility of those who were responsible for this child. And I think if you look into this, you see that mostly when we ask this question, it points to us pushing a responsibility actually that is up to us towards God. That if you, for example, if you look at it in another way, where you say, okay, what would be the perfect solution then? Would it be that no matter what, would it be that there's absolutely no suffering in this world? I mean, that would be perfect, you would guess, but it would also mean that whatever we do, there could not be no suffering. So however hurtful we were to other humans, however evil we were to others, it would be not lead to any suffering, anything that might hint at at something going wrong or something. I mean, I think if you logically try to think it through, you should come to a conclusion that this would also not be just or could not be just, and it would something where we either are prevented from doing what we from having free will, or where we can do what we want and it just has no effect. So we would also have basically no free will, because whatever we do, it won't have any effect. So where's the free will in that? So if you just make these two statements that a God creates humans who have free will, then it is there needs to be the responsibility to go against suffering and so on. It needs to be on us and not on God himself. And therefore, if you also look further into the gospel accounts and into really what Jesus did at the cross, then you see that God himself really did everything to alleviate this, did everything he possibly could to free us from this state, to free us out from the state which we brought upon ourselves by becoming man and by doing by carrying all this for us at the cross and delivering us from it. So if you really look into it, you see there was in the first place it was on us. It is our responsibility. And in the second state, you see that he still took as far as it was possible the responsibility on him by dying for us at the cross and freeing us from this sinful nature. So to answer the Theocidy question is to say, yeah, it is actually it is our responsibility and not his, but he already has taken up our responsibility and delivered us from it. So of course, if you look then closer, you will still see there's still suffering in this world. Unfortunately, there's still injustice in this world. And there, where you also not always can understand, as I said, the direct causation of this, where you don't understand why does this person have to suffer where others who been way worse don't have to. And I think in this context, you really have to make this leap of faith where you really say, okay, but can I believe that God's justice is greater than what I can imagine? Can I believe that in the grand scheme of things, beyond this life, beyond this world, in the eternal world in which God is living, that there is still justice coming to be, that the complete justice of God will be really fulfilled there. And I think this faith, I can have this faith, and I can say, even if I really don't understand what everything that happens, really don't understand every suffering that occurs, I really can have faith that in the grand scheme of things, God will bring everything to justice, and have faith in that. And also one more thing to state is that if you are in such a discussion where this question comes up, I mean, what I was answering it in a pretty logical way, which is not always the solution, or is seldom the solution, because this question usually, as you can easily imagine, is not a question of explain to me logically why this occurs, but usually it's an emotional question. Because if you ask why is suffering in this world, why can God allow this, this is usually referred to something personal that you experienced, personal suffering or a loss of a person that you think was unjust or something like that. And therefore it's an emotional question which can only answered emotionally and not in a logical way, which would seem in most cases, I guess, insulting to that person, understandably so. So if you are in such a discussion, maybe don't come with that logic, but instead come with empathy. And really, if you are yourself in such a situation where you ask yourself questions, where you ask yourself, how can you allow such things to happen, then really make the step of saying, okay, I don't know everything. I think you have to have this humility, and I know that you are God and that you are greater than me and that your ways are greater than mine, and that even if I don't understand it, that your ways are perfect and please reveal yourself to me. Then if you have this posture, I think it will be a lot easier to deal with these questions, and I think you will also get then answers for yourselves. Maybe not answers who can be logically conclusive in all ways, but answers you can live with and answers you can accept for yourself, and that will help you to continue on. Episode 16: Eternal Inflation and the Limits of Science. So, what is meant by inflation? If you hear the term these days, you usually connect it to economics, to the increasing prices also that we are currently experiencing, unfortunately. But in physics, you need something different than that. So what is meant by inflation in physics? I mean, it's a similar concept, but what you mean by this is the extremely fast expansion of the universe in the Big Bang. So there was a period. It is assumed today, so there's no clear evidence for it or no conclusive evidence of it, where the universe was expandingly in an extreme fast way, in extreme rapidly, faster than the speed of light in some cases. And this is believed to have happened in some state of our universe. And the reason why this is believed is because the universe appears to be more ordered than it should be, or under a usual expansion in the time span of 13.8 billion years that we assume now is the age of our universe. So this is the reason why we believe that such an inflationary phase took place. And there are certain parameters of these theories in which you can twist, and where you can get a prediction that the universe repeats itself, basically. And what happens there is that the Big Bang in this case was not the actual beginning of the world, it was only the beginning of our universe. So in this case, there was a universe before the Big Bang, and this kind of crushed into, so I guess this is how it is expanded, it kind of fall into itself into one point, and from this one point the Big Bang happened and our universe was created, and therefore there's always this creation and annihilation or crunching back of the universe, and there are repeating cycles in which universes come to place and are removed again. So this solves not only this problem of our highly ordered universe, other than it is expected from other estimations, but it also solves another problem in science, and that's the fine-tuning problem. And this is the same case. I mean, if you look at this whole, it is really similar to what we discussed in some episodes before of the many worlds, or of multiverse. There's also in string theory, there's also the concept of multiverses coming up. So this is a pretty common concept. And if you look at this concept that is discussed there, or that's currently really popular in science or among scientists there, it is basically the same thing, just not at the same time. So where in general, when you're talking about multiverses, you say there are a million different universes next to ours at the same time, in the same, I mean, you cannot say at the same time, because each universe would have its own time standard, so it doesn't really make sense to talk about it, but you do not still assume that it kind of has a time synchronicity. But in this case here, there was this universe, it crunched into a point, and from the Big Bang came our universe. So you have a sequence of universes, and the whole sequence you could describe then as this multiverse. But still, there is this fact of multiverses, and what is philosophically interesting on multiverses is that it solves this fine-tuning problem, because the fine-tuning problem is this question of how can it be that parameters in our universe are so perfectly tuned to allow for human life. I mean, I made an episode on this. I think I made it on a German podcast, but if you want to hear more about it, there is a blog post about a fine-tuning problem on my Substack, also in English, so you can read it there. And there it is about this really nice feature of our universe that seems to be really nicely tuned for us to experience life, to be alive, to allow for life. For example, there's this weird feature that at the energy levels, which we discussed in previous episodes, of carbon, they are at a certain point, which is just, if you put in the calculations and compute it, it's just, okay, some number that comes out. You don't see any causation. You don't see anything why this number has to be it. It's just an result that you get, which is basically pretty random. But if you look continue to look at it and see what really is needed to have life, then you see that carbon really needs to have an energy level like this for life to be able to exist. So this is pretty interesting to see how finely tuned our universe is to allow for life. But this question is that the question is then, how is that? How can it be? How can we explain it? How? And one solution to this, of course, is to say, yeah, well, there's not only our universe, but there are dozens, bajillion, many different universes that exist. And if you have randomly generated so many universes, chances are that in one universe, it will all fit perfectly well. So, for one thing, this would take extraordinary many worlds or universes for this to make to work, but there's in general no limit to how many worlds there can be. But I think what it shows is that, I mean, in some degree, it really works at the limits of science and in the area of faith already. So many times I heard this argument made by believers who say, yeah, they believe, the scientists say it's some multiverse that is responsible for this fine-tuning problem or that solves this fine-tuning problem. And this is basically the same as believing in a God who created the world such that it perfectly fits. And this is really true to some degree, but the counterpoint many scientists have brought, which also has some truth to it, is, yeah, that might be, but there is really evidence for these multiverses. Of course, this evidence is already interpreted, so you have these facts and you interpret it in such a way, and then you get these multiverses, but there is still a correlation of the real theory and where you can really see how multiverses would come out of it kind of naturally, but it really is not baked into the equation. So I would say it's maybe something between, but it's also, if you have listened to the episodes before about interpretations, and there it's also clear that the interpretation, for example, the deterministic interpretations of quantum mechanics, they come because that's the worldview many of those who have these theories have. So the interpretations we get from our physical theories are closer to multiverses because that's the interpretation many of the scientists who bring forth these theories prefer. That's also the argument you can bring. So I think there's still a valid case to be made that this is the area of faith and not anymore of science, and that just as well as you can believe there's a God who created a perfect universe such that everything fits and life can grow there perfectly, just as well you can make the case that there are multiverses who account for this fine-tuning problem. Okay. But what I think is really the case here is that this is already, or what begins to happen here is that we are going beyond the realm of science, beyond the scope of in which science is defined, which is in the scientific method. So everything that can be proven using the scientific method. And the scientific method, for some, they say everything. There's nothing else but what science can show. So nothing else but what the scientific method can show. But this itself is a statement that cannot be established scientifically. You cannot show that this is true, and therefore this statement itself contradicts itself. So it cannot really be true. So there has to be something more than science. There has to be something beyond the scope of science, something beyond the limits of science. And many don't believe that, especially in science, but that's the problem, because then you really don't realize once you have gone beyond the limits of science. And I think there are certainly limits of science, and I think, for example, Feynman already saw cosmology as not really scientific, because it was for him beyond these limits, and at his time this was really true, because there were no experiments that could be made confirming cosmological assumptions, and therefore one needed to say, yeah, that's not really science, that's some other thing. But I think even still today we have some measurements we can make, some facts we can obtain with which we can prove cosmological assumptions, but still there is really the limit of science in my eyes coming closer and closer, and this is really something we need to deal with. And with that, just as a small caveat, with this I do not say that science will soon reach its end or something like that. We will never be at the end of science. We will always find out new things. Many have said that we are closely to the end of science and we will finish soon, and studying physics does not make any sense because we are almost finished. Many have said that, and right afterwards, great new fields of science were explored and found. So that's not true, and I think it will never be true. But I think there is an area where the scientific method reaches its boundaries, where you cannot go beyond that, and where there is more, and if you don't believe that there's more than what we can know scientifically, then you go into danger to really don't realize when you have gone past that limit, and then you will call things scientific that are not at all scientific, and go in this area. So one example where I think that the limits of science are about to be reached is regarding consciousness. I think consciousness itself is not a purely scientific process. I think there's a spiritual component to it, and I think this is where we reach a boundary where many argue that consciousness is an emergent concept and stuff like that, which is already kind of hand-waving of saying, yeah, if you have that much nuance and particles and things together, something like consciousness just emerges out of the blue, which you could not see at individual neurons colliding or something like that. Which is really hand-waving. There's no clear equations behind it. It's just saying, yeah, it somehow occurs. It's kind of like in this cartoon where the creationist says, yeah, there's some miracle occurs, and then there's this universe. Somehow in the same way, many scientists are arguing now and saying, yeah, some emergence stuff occurs, and then there's consciousness. So, and this, I think the reason for this is, to some degree, that it is, of course, not at all understood what consciousness is, but also to some degree that it is, I think, not possible to understand consciousness in a purely scientific way, and it is beyond the scope of science itself. And therefore, if you try to understand consciousness by purely scientific means, you are deemed to fail. And you will not realize that you are past the boundary of science, since you do not believe that such a boundary exists. And then you are deemed to make assumptions, or make your assumptions be scientific. You say you make assumptions and you say, yeah, this is science says so, because you have some evidence to on which you rely on this. And I want to move away from the topic of consciousness, because I think in a later episode we will look deeper into this. But to go back to cosmology, I think there you have the same area where you say, okay, we have some evidence that something like eternal inflation could occur in our universe, and then you say, okay, if we can prove or if we say internal inflation makes these and these predictions, which are nothing at all like, hey, eternal inflation is happening, but rather like some particles behaving in such and such a way, then some people are arguing, okay, this then proves that eternal inflation is a thing. But on the other hand, it could completely be that even with that description, that there is an alternative description which says these particles behave in such a way for a completely different reason. And there you see that the limits of science are reached there, and in this way the interpretation of the scientific facts and the facts themselves are in some way so much apart that you kind of cannot really talk anymore of saying that this interpretation is definitely true, because the facts are so far from it. But because how would you could not be really certain of something like eternal inflation to have occurred unless you have been there, and you could not have possibly been there. So this is, I think, the problem in which modern science is currently running. And I think if you read about topics that go in this direction, that go in such big models about eternal inflation, multiverses, consciousness, and so on, really ask yourself, if somebody writes about it, ask yourself first, how can they know this? And if they certainly will have facts that they use for their assumptions, but you will clearly see that those facts are not so close connected to their interpretations, that while their interpretations might really be valid, there clearly can be a completely different interpretation that would explain the same effect. And therefore, I think this is what, especially in these times, we need to be careful of when we are interpreting scientific findings, to separate this interpretation a scientist has to the facts that he presents, or the findings that he presents, from the real facts. That we have the separations and really understand, okay, while the facts are valid and true, apparently, there still can be a discussion about how to interpret these facts. As a final note on this, let me just say that the same problems that this eternal inflation seems to solve, so the problem of a universe which is more ordered than it is supposed to be, and this concept of the fine-tuning of the universe, both can be also perfectly explained by creation, by a creator who creates the world such that it perfectly fits life and such that it is perfectly ordered, or such ordered as it needs to be. So this is already a perfect explanation of this, and therefore it can be not only seen as something which needs to be described in such a theory, but also it can be seen as something which hints at an creator. So that's everything for today's episode. I hope you liked it and you enjoyed each part of it. If you want to get in touch with me or discuss a topic or want to give me some feedback, then feel free to contact me using the contact form on my website, sci-faith.de/en. And there you can go to the contact tab and contact me. And if you have any other things or episodes you want to have covered there, or topics you want to have covered, feel free to contact me there. Also, if you are not yet familiar with the format in which this podcast is produced, let me just briefly explain it to you. So there always at the beginning of a month or of a block, there is a big block of 4 episodes in one thing. It's kind of like a preview, which I call it, where you have the next 4 episodes all in one episode together, combined. And this is for people who like to hear long format podcasts, who have a long way to work or something else, where they can listen to a long episode and can then have a preview of the next 4 episodes all at once, and are completely up to date from the beginning of the block. For those who like their episodes shorter, who prefer it if they have a half an hour or even less of a podcast episode, for those there is every week afterwards will appear a podcast episode almost in that length, and this way I can publish every week a new podcast every episode, and everyone can have it his own way, either once a month a long chunk of content, or once a week a shorter format podcast episode. So I think that's the best way for everyone, and also for me when I'm producing it. Please also note that this is an independent podcast, which means that it is recorded, produced, and marketed by me. So I really need your support in this. So if you like this podcast, then give it a 5-star rating. And if you have the time, even write a review to it. This just helps other listeners to become aware of this podcast. And then people who might be interested in this content can become aware of it. Also, if you have friends who you think would like this content, then recommend it to them and share it with them. Also, you can support me in other ways, for example by reading my blog and subscribing to my newsletter, or even by reading my books, which you can find on Amazon. For example, there is my latest novel out now is Alien Thoughts, which is pretty entertaining from the feedback that I gotten, and so it's also in some way related to science and faith. The topic of it is also in there, but of course you can also read the book to this podcast, Sci-Faith, The Compatibility of Science and Faith, which is also available in English since last year. Thank you for that, and now I wish you a wonderful day, and I'm looking forward for you to tune in again next time.